Welcome to part 2 of these tutorial courses. In this part, we will go through a very simple project. It doesn't really mean anything. It's just a simple board to let you see the entire process from start to finish without explaining the tools in details, without explaining every button. Just let you see the entire process of design from start to finish. And before we start, I'd like you to visit thundertronics.net, and I'm gonna put some links in here and some news about my store and in future technical blogs. And visit thundertronics.net store to buy my stuff when they are available. Right now we have the Thunder Dreamcast power supply available. And subscribe to my YouTube channel. And let's press the like button and share and spread all these videos to your friends and colleagues. So let's get started. First of all, I'm gonna make a new project like that. I'm gonna put it in, for example, where are these tutorial course projects, the simple project, and I'm gonna call it simple project. Save. Now I have the project, I have the schematic sheet, and I have the PCB layout board. Let's open the schematic sheet first. Control S to save, and we have the root page. In this tutorial we'll only need that root page. So we'll be designing a 5 volt to 3.3 volt regulator. Very simple, just a demonstration of the idea. It's not a real product and it may not be beneficial for you. It's just 5 volt to 3.3 volt regulator. So let's start by opening the library. I'm gonna search for my regulator, which is the AMS 1117. I want this part. As you can see here, AMS, I search. I have every library available, and with the keyword, it got to me this package right here, and another one, the CD one right here. Let's choose that, for example, and I'm gonna place it right in here. Next, I will be choosing a capacitor. Let's go the capacitor C small. For example, this is the symbol, or you can pick the bigger symbol. I'm gonna pick the small symbol. I'm gonna put it in here, and I'm gonna say that I want a polarized capacitor, for example, and I'm gonna put it right here. So let's connect these, for example, like this, by pressing the either connecting the mouse button to this node or pressing the W wire like this. Okay, so I have this, the W. I can keep routing, but I don't want that. Now let's put a power symbols from here. I'm gonna search for ground, GND. Where's GND? This is GND. This is the ground. Move the ground right here and make it nice and simple, just like that. Now I want to make this small capacitor a 100 nanofarad, and this one I want it to be something like maybe 100 microfarads or something, or maybe 22 microfarad. A polarized capacitor, maybe electrolytic, maybe polymer. Now let's put these two. Press Ctrl D to duplicate and put them also at the input, because you have to have an input capacitor as well. And I'm gonna connect these right there, and of course like this, delete, and like this. Organize it, make it nice and simple, like this, and like this. So now we have connected our inputs and outputs. Here I'm going to choose, for example, a USB connector, USB type B or micro B. Where's micro B? USB type B. No, I want the micro B. This is the micro B, and we're gonna put it right here. This is the V bus. Escape to exit the component placement and go to the other route, and ground basically to ground. I don't want these other pins for now. I'm just gonna put the no connect here, and the shield is always connected to ground. Maybe you can ditch that, but in this tutorial we're gonna choose it. Control S to save, and maybe move that here, make it nice and simple. And I'm going to make a connection out of this, so I'm gonna make let's put CON for connection. I'm going to have a let's put it a connector screw terminal like this. This is a screw terminal. First one for the positive and the other for the negative. Now everything for us is now determined. Now go to the power section here and put something like 5 volt, the symbol for 5 volt for power. This way, this net here is labeled as 5V, and the same for not the component but the power symbols. The same is for 3.3 volts. You can choose basically as many variants as you can check. For me, I choose the default 3.3 volt, and that's about it. Control S to save. Now that we have drew our schematic, it's very nice. We are satisfied with that. Now we go to next step, which is the edit symbol field. Open that, and now we have the 100 nanofarads, the 22 nanofarad, basically every component that we have. And we're gonna choose right now the footprint for all of these components. Knowing from design experience, the 100 nanofarad must be as close as possible to the pin and to be a very small package, while this one can be a larger package. So I'm gonna choose for 100 nanofarad, I'm gonna choose a footprint that is 0402. Let it load. This is the footprints library. So I'm going to go to the capacitor surface mount like this, and I'm going to choose 0402. Now we have another 0402. It's called hand solder, which means this pad is a little bit extra. I don't want that. Let's go for this. So now all of these 100 nanofarads will have the same footprint. Now the 22 microfarads, it is a bigger capacitor. I'm gonna choose also an SMD capacitor. Maybe go for something standard like 6.3, and maybe this one. Maybe this one is a standard capacitor, or maybe that one. It's basically the same footprint, but the length is different. I'm gonna choose this one. Okay. Of course, now in real design, you have to add another field right here. It's called, for example, let's go right there and add another field. Let's call it part number, for example. Okay, now I add the part number of that certain capacitor I'm interested in. Maybe add another field for supplier number 1 link, supplier number 2 link, etc. Basically anything that you want, but for this project we don't care. Now for the the USB micro, let's pick the USB micro. This one is available, and let's search for micro B, and we have basically as many variants as possible. Let's go for example with this small X part. Maybe this one. No, this is vertical. I want something not vertical. Through hole. Vertical. No, not vertical. I want horizontal. This one is horizontal. Okay, let's go with this one. But this one is SMD, but with this, okay, and this one, let's say that this one is this one is the one that we want. Now for the screw terminal, again, let's go for screw terminal block, and let's pick something. No, not necessarily screw, but terminal block, terminal block, 02 pins. This one. Okay, terminal block. Okay, let's pick this one. Okay, and we can change it later on. There's no problem. But let's check, for example, that this one is the one that we want. And you notice that the 3.3 volt regulator is already having its own package. It's already there. So I say apply, save, and continue. Okay, now it is saved. All the footprints are basically there. It's nice. Next step is you go to of course, as we assigned footprints, because you can assign footprints from here like this. It is maybe easier if you go, for example, the terminal block. You can find all the terminal blocks that you can basically imagine. For example, let's see if we have something a little bit better. For example, let's pick this one, apply and save. Okay, so now you go to the electrical rules, check. Now run. It will now check for errors, and there are no errors at all. So we can safely save and close this and go to the PCB. Open the PCB, import everything from the schematic, update PCB, and yes, there they are. Let's go Alt and 3 to see the components in 3D, and there they are. Now, of course, they are still not that much selected and routed, so we will close the 3D look right now, and we'll start doing the PCB. Now, first of all, the PCB is go to the board setup. In the board setup, here we define how many layers, the stack up. Let's go to the physical stack up. I only want 2 layers, and I'm okay with all of that. Board finish, etc. Solder mat, everything. You can basically go through that and select that. We'll go through that in details in the next episodes. And here is the constraints, how many, how small the holes can be, and how small and how tight the tracks against each other. It basically depends on your manufacturers, but 90% of the time the default is okay, and we can basically say okay. So now we have to define the first thing after the board setup and saving is go to the layers. Here are the layers, the copper front, the copper back, etc. I'm going first to something called edge cuts. This determines the shape of the entire PCB. So for me, I'm gonna choose a grid of, let's say, 1 millimeters, and let's start draw. Not necessarily 1 millimeters. Let's go for something like 5 millimeters, and let's draw a board that is 10 by 50, for example. Done. So now when we go Alt and 3, see, this is the board and everything else is now outside. We can fix that. Okay, let's start by lowering the grid to something that we can work with, and let's start connecting. The USB, it's gonna be connected right here, for example. This is our regulator. Put it here, for example. And this is the output connector. basically you can just put it right here as a preliminary placement. Now of course this is very big, but you get the idea. The idea is that it is something as an explanation. And we go back to the schematic, and now we can choose the input capacitors. And if we go to the PCB, they can be of course highlighted, and bring them up. I choose this, press M to move it, and it's gonna be right here between the 5 volts and the ground. And of course this one is going to be like this as well. Maybe this way is also better, but let's make it this way. It's not the best layout of the world, but we can manage. And this one is also the same. And we'll bring the other capacitor also in here. Press R to rotate, for example, and I'm going to have a problem doing it like this, so I'm gonna move that to here, and I'm going to basically rotate this to the other direction because the ground pin is outside. It's difficult for us to reach it from here, and I'll tell you what are we gonna do about it. Okay, so maybe we decrease this to something more manageable, like this, for example. Move, select and move. Now I think I should add another capacitor, for example, maybe another 22 micro, and I press here and duplicate. It duplicated it. I reattach it again, press save. Okay, so now get back here and re-import the changes. What is the change? And I added a C5 with the same settings as the previous one because I duplicated it from it. Okay, and it's here. Let's make room for the new capacitor, maybe like this. And the new capacitor is basically gonna be connected right here to make a shorter path. So now let's make it even tighter, like this. Okay, so Alt and you can see Alt and 3, it is perfectly fine except for this. Okay, let's try to move it to maybe in the center. You can basically fine-tune it forever. Now here it doesn't have a 3D model for some reason. I'm going to choose another 3D model. I'm going to go to connector and let's go connector USB micro B, this one, or maybe no, this is mini B. This one is the Molex. Okay, Molex, this guy. Okay, maybe another topic we can choose is go back to the schematic and maybe select the footprint from here, which is USB about the Molex. This one is the Molex USB micro Molex. Which one was the one with the footprint? Maybe it's this one. Okay, now we have changed the footprint. Get back to the PCB. Now update. The footprint has changed. Now does it have the 3D? Yes, it does have the 3D. What if the 3D model doesn't exist? First of all, it doesn't need to exist because you're gonna solder the real component. It's just for aesthetics. Second of all, if it doesn't exist, you may be going to the manufacturer or the supplier. They can give you these 3D models and you can add them basically like this. Go in here and going to the 3D model and then search for it and add it. But this is not the topic of this video. Let's move it to here, and these ones are gonna be moved maybe like this. Middle mouse button here to click to make it the orient page, the orient point. And we can basically see our awesome power supply, 5 volts here and 3.3 volts output here. The capacitors always work exactly like we want them. Now we need to basically route everything. For example, first I'm going to go to the second layer and I'm going to fill it with ground. Let's put here the ground. I choose G and D after choosing the proper tool, and basically make a big ground pour. Close it. Now it is closed. Escape to exit. Press B to fill. Now the entire bottom board is ground. Now let's go to the upper board. The upper board, the upper layer is the 5 volts and 3.3 volts, etc. So let's start by doing the 5 volts. For example, I'm going to start with another polygon pour. Start from here for 5 volts. 5 volts, like this. Let's go here, and let's go outside to here to basically cover the pad, roughly speaking, not necessarily an exact and close the polygon. Maybe make it finer. Now it is closed. Press B. Now it is done. But notice the placement, the clearance is not really that much because it doesn't get in here. So I'm going to go to here to clearance, override pad clearance, put something like this and make it okay. It does do that, but let's make it a little bit less. Make it maybe 2.5. Okay, so now I'm gonna choose this polygon pour and I'm gonna convert it from thermal reliefs, which is this guy, to solid. Convert it to solid. Fill it. It is filled. Now this one is gonna be maybe bumped back to 1 to 5 to make it a little bit okay, fine. So now 5 volt is there, and we need a 3.3 volts basically. Let's move this to this side, make it like this, and make the entire thing a little bit less than that. Now it is perfect. Now let's do the same for 3.3 volts. Maybe go to another one like that. Going from here, 3.3 solid. Let's make it solid from now, and let's start doing that. Maybe like this, roughly speaking. And now, and close it. B. It is nice. This one is moved outside a little bit. B. Fantastic. Okay, even more. Fine. But you notice that the 3.3 volt also should go to the other direction. let's make the other direction also available by extending this guy up to here, for example, and then I'm gonna insert a new point like this and another new point like this, and look how can I divert that right here, and no, and grab this point. And from here add another anchor points and move the entire thing down like this. To basically cover the area. Routing polygons, guys, for power rails is always better than routing them manually. So now we have a entire piece of the 3.3 volt. Let's add another one like this to cover the pad. Make it as neat as possible. And press B. Now the 3.3 volts are always connected perfectly fine. We can of course move these capacitors to the other side and basically so on. But that's a topic for a different time. Now after we have finished this, we're gonna make another polygon pour, or not maybe another polygon pour. Choose this polygon pour and make it also for the top layer, because we want ground also for the top layer. Press B and it will fill everything else with basically ground. And maybe I can just select it again and never select thermal reliefs. Maybe I want to select solid, so that the thermal reliefs that you can see here are gone. It's up to you. It's something about the design itself rather than just the layout. Now we have basically everything that we needed, but we need to connect both ground layers together. We do that by making vias. This is the via by pressing the this button. I have selected a via. Okay, so I can select via size, maybe not like, okay, this is the via or via. We can go to this diameter, maybe make it a little bit bigger, 0.8 and 0.5. This is a via. We can basically copy and paste it elsewhere like this and like this. I can select these vias and maybe going to the align and distribute and align them together, then going to align and distribute and distribute them, maybe distribute them horizontally. Yes, now they are horizontally distributed. Copy and paste, make them near the ground pad, copy and paste like this. Now for every capacitor we need to put some as well, like that, and here is also very nice. We can rearrange that also next time, and maybe put something like this here and maybe move them closer together. See, now we have stitched the ground layers together. We made short path from the ground via to the ground for all of our capacitors. Maybe also have put under the capacitor right here. This is something really nice. always short path to ground for capacitors. For every ground pad you should put some ground vias like this, and for the regulator as well. You can basically keep fine-tuning this until you are satisfied. More vias, of course, more ground and more thermal management, and more shorter path to ground, least inductance path to ground, etc. Especially this main ground pad and the other main ground pads like that. That is something that is very nice to add like this. See, each ground pad, short path to ground to the via next time. Maybe if you put one via for the entire connector, maybe all of the current will go through here, and maybe that's gonna make a problem, because current will pass from the 5 volt to the regulator, going to the output, getting back all the way to the regulator and back through these input or output caps, I'm sorry, and going to the ground pads of the power supply that we have done. Now these will have, if it's just one via, it's gonna be a problem and maybe not enough. So it's always better to have vias. Now since we have surface mount, only one layer is just enough for that, but it's always better to have 2 layers, ground pours everywhere, stitched everywhere. Like for example, we have this area right here is not really connected. Let's stitch it out. Very nice. And let's say that we are satisfied with that. Control S, Alt 3, and this is our design. Now next step is basically to go to saving, of course, then the design rules check. Let's check the board, maybe it's faulty. Run DRC, design rules check, and gave us 0 errors. That means this is electrically connected, it's electrically fine. We can manufacture it and we can make boards that run perfectly fine, but it has warnings. Let's go to the warnings. These are the warnings. Okay, let's go about these warnings. Press the first one. It tells me that this silk screen is outside the board, or nearly the edge cuts. Let's go and check it on 3D. See, this is what it is. It tells me that this thing is outside. Now you can go to the component footprint and you can remove this, or maybe just let this get back more, but this is just cosmetics and it will never affect anything. Okay, let's go to the other side. See, this one is affecting the pad. This C3, which is this one, is affecting the pad. So I'm going to basically move it to here. This is C4, it's on the pad. So I'm not gonna lose anything by making it tighter, neater. This is C1, I'm gonna make C1 similar to C3. This is C2. Look, that C2 is coming from the pad. The drill, when this thing is done, is gonna drill through the number 2. So let's make it maybe like this. Nice and simple. J1, let's make J1 a little bit farther so it can be seen. And basically U1, for example, U1 is also fine. Let's make it right here. C5 is nice. J2 is not nice. J2 can be something like, move it, can be something like this. Okay, let's make another design rule check. Now only one warning, which is this warning, so I'm gonna fix it regardless. I'm going to press edit for this footprint. Let's edit footprint, and basically I'm going to put it maybe right here. This is pin 1 indicator, for example. Let's put it right here, and let's connect these two again. Fine, let's save it. Now this is the local footprint, so I'm going to press here and update footprint. Let's say update footprint, or did it update? Oh, okay, it did upgrade. Because this is the local footprint on the project. The main footprint on the library is still the same. It's still always getting us this error. So what is this right now? Terminal block horizontal does not match. So it tells us that the footprint that we are using does not match the footprint in the library because I moved this. So I'm gonna basically just ignore this warning because I know for sure it's not bad. Alt 3, now everything is fine, everything is aesthetically nice, and we can basically move on to maybe going to the silk screen layer, which is the drawing, and I'm going to write something. Write simple voltage regulator, make it 2 by 2 by maybe 3, make it like this. No, it is too much. Okay, it made the font a little bit less. Make it like that. Okay, simple voltage regulator. And we can make it maybe knockout if you like this kind of shape. And that's about it. Let's put 5 volts to 3.3 volts. Bold. Okay, save. And now our little project is done. I think it's perfect. Now, if I am satisfied with that, I'm gonna save it. Okay. So now we're gonna manufacture it, right? So we go File, Export or Fabrication Outputs, the gearbars. The gearbars will going through this simple project. I'm gonna make a folder called gearbars. Let's select that folder and make plot. Let's choose the other layers. Basically, we want all the layers that are important and make plot. Now it is plotting. Generate drill files, basically generate and then close. Let's go. Fabrication output. We have generated the drill files. Component placement. The output maybe okay. Maybe here in the main. Maybe it's in the main directory of the project. Yes. And generate position files. The position files are the ones that tells the machine or the operator where exactly to put these components on the coordinates. Let's go next step. Of course, save. Next step, the bill of materials, but we have seen the export. Nothing is here to export. Now we have to go to bill of materials and export simple project CSV, or maybe just bill of materials, just make it CSV. Okay, now it has exported it. Let's go to the project directory from here and tutorial courses, simple project. This is the bill of materials, and of course it is in the CSV format. No problem. We can go to, my way is to go to data. I'm going to make it, yes, from text or CSV. And basically we need to choose our, let's go to tutorial courses, simple project. Give me this. Okay, load. So it loaded. Now Control S to save. It is saved. Now let's export it or save it as here as a Excel workbook, which is something that, let's call it complete for change. Save it as an Excel sheet and delete this CSV export. See, now you can just use your skills to make whatever change that you want. This is our bill of materials, okay? Now you can basically add as many as you want and change the shape, change the color. And what I advise you to is just the supplier. For example, this one is maybe a capacitor, let's say Panasonic, whatever the part number that you choose, and this one and that one, and then go to maybe supplier number one, or maybe DigiKey, for example. This is a supplier, DigiKey part number. Go search for DigiKey part number, and let's say LCSC part number, because LCSC is very, very competitive in its pricing. Now you can check all of these components that you already have in your design, put the original manufacturer or just the part number itself, the original part number, the DigiKey part number, and the LCSC part number or Mauser or whatever supplier that you have. And I advise to also put a alternative part number, because not always you will have a part number that's always exists. So I suggest you have a replacement in case something is out of stock. Let's assume that we have completed everything. We can press Ctrl S, and as a demonstration, I will go to LCSC capacitors, for example. Let's go for the multi-layer ceramic capacitors. I'm gonna choose in stock. I'm gonna choose the 0402. Then I'm going to 100 nanofarads. Okay, apply. Basically, I need it to be 6.3 volts or more, something like this. Okay, totally fine. Sort it. I go, for example, Yego is a nice company. X7R, 16 volt, very nice. And I'm gonna choose this. This is, or this one. This is the original part number. Let's go to 0402. This is original part number. See, now you can see that. And let's go to the LCSC part number is this one. Each supplier to have their own, so you don't have to basically copy paste me. This is LCSC part number. Save. Maybe it doesn't exist even in DigiKey. Let's try to find it in DigiKey. Okay, it does exist in DigiKey. And this is DigiKey part number. You can basically check any one of those, cut and tape, maybe this one, or tape and reel. Copy, go here, and paste. And do the same for everything. Now you have completed the bill of materials, you have completed the layout. Your Gerber files are in here. These are the Gerber files. You can basically zip them together as .zip folder, and you can apply it to your manufacturer and get your board made. Ctrl 3 or Alt 3, I'm sorry, to have the 3D print. Maybe go and do this for a nice little view, 3D rendered in ray tracing. And that's all there is to it, to this tutorial. Now you have seen everything from start to finish. Very simple project. It doesn't mean anything. It's just for us to experience the software. Next, we will start to dig into all of these tools one by one in order to master how to use them. After that, we'll use a bigger project. So stay tuned, subscribe to the channel. Please share the videos, share the playlist itself with your colleagues, and check thundertronics.net again. I'm gonna start putting stuff in here. These are articles. I'm gonna fill it up when time comes. Check thundertronics.net store if you are interested, and basically subscribe, as we can see, as we said, and that's all there is to it. Thank you for watching this tutorial, and stay tuned because other tutorials are coming.